Good morning. I'm Lamia KK from Department of Computer Science. Today I'm going to talk about Integrated Services Digital Network. What is ISDN? ISDN was introduced so as to digitize the telephone network to standardize subscriber services, provide interface between user and network, and facilitate the internet working of existing voice and data networks. History of ISDN. Initially, telecommunications networks were entirely analog networks. With the rise of digital processing, modems were developed to allow digital exchanges over existing analog lines. To reduce costs and improve performance, the telephone companies gradually began to add digital technologies while continuing their analog services to their customers. Three types of customers were identified at this time: traditional customers using their local loops only for analog purposes, customers using analog facilities to transmit digital information via modem, and customers using digital services to transmit digital information. Customers began to require access to a variety of networks such as packet switched networks and circuit switched networks. To meet these needs, the telephone companies created integrated digital networks, which is IDN. An IDN is a combination of networks available for different purposes. Access to these networks is by digital pipes, which are time multiplexed channels. The ISDN integrates customer services with the IDN. Initiative was to replace the analog local loops with digital subscriber loops. Voice transmissions can be digitized at the source itself. ISDN will then allow all communication connections in a home or building to occur via a single interface. Each user is linked to the central office through a digital pipe. These pipes can be of different capacities to allow different rates of transmission and support different subscriber needs. This is the diagram of Integrated Services Digital Network. Now let's talk about the common uses. It is used in voice calls. ISDN offers high quality, noise-free voice calls. Second one, video conferencing. Supports video conferencing by allowing high quality video and audio to be transmitted. And next one, internet access. Provides faster internet connections than analog system. Next one, fax transmission. Enables faster and clearer fax transmissions. Subscriber access to ISDN. To allow flexibility, digital pipes between customers and the ISDN office, which is the subscriber loops, are organized into multiple channels of different sizes. The ISDN standard defines 3 channel types, each with a different transmission rate: bearer channels, which is also known as B channel, data channels D channel, and a hybrid channels, which is also known as H channel. First one is B channel. This defines data rate of 64 kilobytes per second and can carry any type of digital information in full duplex mode. Second one is D channel, 16 or 64 kilobytes per second. The main function is to carry control signaling for the B channels. As opposed to in-band signaling, where control information such as call establishment, ringing, call interrupt is carried by the same channel that carries the data. ISDN separates control signals onto a channel of their own, the D channel. This method is called common channel, which is out-of-band signaling. Therefore, subscriber uses the D channel to connect the network and secure a B channel connection D. Therefore, subscriber uses the D channel to connect to the network and secure a B channel connection. D channel acts like an operator between the user and the network. Third one, H channels. Data rate of 384 kilobyte per second, 1536 kilobyte per second, or 1920 kilobytes per second. These rates suit H channels for high data rate applications such as video, teleconferencing, and so on. Next one, user interfaces. Digital subscriber loops are of two types: basic rate interface which is called BRI, and primary rate interface, which is called PRI. BRI specifies a digital pipe consisting of two B channels and one 16 kilobyte per second D channel. It is designed to meet the need of residential and small office customers. Next one, PRI specifies a digital pipe with 23 B channels and 164 kilobytes per second D channel. Functional grouping. Functional grouping defines the function of each type of equipment used in the ISDN. A functional grouping is shown below. This is the diagram of the functional grouping. The subscribers choose the specific devices best suited to their needs from these groupings. Network termination 1, which is called NT1. This controls the physical and electrical termination of the ISDN at the user's premises and connects the user's internal system to the digital subscriber loop. Network termination 2, NT2, performs functions at the physical, data link and network layers of the OSI model, which is layer 1, 2 and 3. NT2s provide multiplexing, layer 1, flow control of layer 2 and packetizing layer 3. An NT2 provides intermediate signal processing between the data generating devices and an NT1. Terminal equipment 1, TE1. The same thing as DTE, source or destination of data. In other protocols, it refers to digital subscriber equipment. Terminal equipment 1, TE1, is any device that supports ISDN standards. Example, digital telephones, integrated voice or integrated data terminals, etc. Terminal equipment 2, TE2. TE2 equipment is any non-ISDN device, such as a terminal, workstation, host computer or regular telephone. TE2 devices are not immediately compatible with an ISDN network but can be used with the help of another device called a terminal adapter, which is a TA. Terminal adapter, TA. A terminal adapter converts information received in non-ISDN format from a TE2 into a format capable of being carried by the ISDN. Reference points. Just as the functional grouping defines the function of each type of equipment used in the ISDN, a reference point defines the functions of the connections between them. This is the diagram of the reference points. In this picture, reference point R defines the connection between a TE2 and a TA, and the reference point S defines the connection between a TE1 or TA and an NT1 or NT2, if present. Reference point T defines the interface between an NT2 and an NT1. And the reference point U defines the interface between an NT1 and the ISDN office. So, in conclusion, Integrated Services Digital Network, which is also known as ISDN, represents a significant advancement in telecommunications, offering reliable, high-quality digital transmission for voice, data and video services over traditional copper telephone lines. While its widespread use has been gradually overshadowed by more modern technology like broadband and VoIP, ISDN played a crucial role in the development of digital communication networks and still serves certain niche applications that require stable, dedicated connections. Although its relevance has diminished in the face of evolving technologies, ISDN's legacy in shaping the digital communication landscape cannot be overstated. It paved the way for the digital integration of services that are integral to the modern network infrastructure we use today. So that's all for today. Thank you.